work through different problems in the 3 different classes. So I'll go ahead and record all of those and post them. It's gonna kill my battery life, but we'll do it. So I will post all of those. I wanted to show you the image though. Where did it go? I think it would be in here. Okay, so that's where we were. So, so I'll post all of those so that if there's any that aren't overlap, you can go through and see other problems that I've worked. That should be very useful. Hopefully people ask different questions. Okay, so I'll let you finish the work because I think at this point everyone can do this just fine. How would I ask this question? I would feel fine asking you to determine, so I would obviously give you the pressure of water. I would feel fine asking you to determine the pressure of O2. So you get the total pressure, you get the pressure of water. Maybe I have you determine the pressure of O2, and then I gave you the moles already, right? So like, let's say that it doesn't include the stoichiometry part. It would already give you these moles and all the other data that's there, including this that should be, you know, a constant that you're given. So that could be an exam question. Another way that I might do this is, don't worry about the collecting it over water part. So maybe I just start with the stoichiometry side, the 16.7. You have to calculate the moles, and then I give you this pressure of O2. So this is what I mean by like when there's more than, I'm gonna say 2 parts is probably just like knowing myself and knowing how I write questions. I generally only make you do like 2 different types of calculations. So like obviously a stoichiometry question could involve like 3 different small calculations, but that would be one type, right? Here you've got partial pressures and stoichiometry and PV equals nRT. So I don't think I would make you do all 3. I would just make you do 2 of those, giving you whatever you needed in order to just be able to do those 2. All right, good. Go back to the assignment. Mm-hmm. 29? You said 29, right?
Yes.
Okay. Okay, I'm gonna write on this one too. Okay, so when aqueous solutions of sodium iodide, so the first thing I'm gonna do, since I kind of skimmed over the question slightly, I'm gonna break these into their ions because I already noticed that it was 2 ionic compounds, and then I saw somewhere in this thing that it said precipitation reaction. So if you didn't see that immediately, not a big deal. As you read through the question, you'll get to that point where you realize you have to break them up into their ions. So I'm gonna do that first. Sodium iodide is sodium ions and iodine ions. Lead acetate, and they even are nice to tell you this is lead 2. So Pb2 plus and C2H3O2 is acetate. Technically there are 2 leads here for every 1 acetate. That doesn't matter in a question like this. The only time that really matters is if you're having to write out a balanced equation for a precipitation reaction. Here they just basically want to know if a precipitate is formed. Okay. Which of the following correctly describes what happens when they're mixed? I'm assuming that says. Okay, so because there are 2, so you first need to identify the type of reaction you're looking at. Nobody is an acid or a base. This is kind of a weak base, but we're not going to worry about that because it's not obvious. And you guys probably don't know that yet. Because there are 2 ionic compounds, we can assume that they are going to trade partners, and then we're going to see which of those new compounds, what is the state of each of those new compounds. So I'm going to take sodium and pair it up with acetate, and I'm going to take lead and pair it up with iodine. Okay? So I need to go to my solubility rules, and it says both sodium and acetate actually are always soluble. Let's just go with the sodium rule though, because it's the first one. So all sodium compounds are soluble. So I do form NaC2H3O2, but it's aqueous. So it is formed, but it is not a solid. I have not yet figured out why my pen keeps trying to correct me or tell me when there's errors. Got to do that. And then lead iodide, PbI2, because it was lead 2. Again, I go to my solubility rules, and maybe we should do this just one. Oh, no, don't. It'll take that away from me. If I go to my solubility rules, I'll show you those in a second. It says chlorides, iodides, and bromides, except for when with mercury, thallium. I don't think yours says thallium, and lead. But mercury and lead for sure is on there. Okay? So that one, is solid. So now let's look at our possible things. No reaction occurs. Well, that's definitely not true because they changed partners and one of them was a solid. If they had just changed partners and both of them stayed aqueous, that technically is no reaction. So if you have two ionic compounds, you swap their partners, and the products are both aqueous, that is no reaction because they're just all still dissolved in the solution. They're not actually bonded to each other. Okay? They're not really bonded to each other until they come out of the solution and form a solid. Okay. Precipitate of sodium acetate is formed. No, I just said that sodium acetate is aqueous. These two aqueous solutions cannot form a precipitate because both the reactants are soluble. No, that doesn't even really make sense because I thought it was going to say both products are soluble. That would be true if you had two products that were soluble, but the reactants are always soluble. They're always aqueous. A precipitate of lead iodide is formed. So that's the one. Nice review of precipitation reactions. Now I'll pull up the solubility rules just to show you. Well, I don't think I can go in there because I'm not going to scroll through the exam looking for the information sheet. Let's see. That one is not the one I just updated. Where is it? Oh, I probably stuck it somewhere else. So I'll go ahead and open this one, but there's maybe an equation missing. I updated it on the exam. Okay. Chlorides, bromides, and iodides, except for when with paired, it's silver, mercury, and lead. I said thallium. Okay. So if chlorides, bromides, and iodides are with other stuff, iron, sodium, cobalt, any of those, it's going to be soluble. These are the exceptions. These are the times when it will form a solid. So that's why lead iodide is a solid. Sometimes people have a hard time interpreting what those mean. So these things are soluble no matter what they're paired with, unless there's an exception listed, and then it's just those specific combinations that are not soluble. And don't worry about the ones that say most other compounds are insoluble. If it's not listed up here, it's insoluble. Don't worry about these two. We'll talk more about those in Chem 2 when we deal with hydroxide compounds a lot. $26, sure. This is a great one too. Okay, so this is probably a titration. It doesn't say that in the question, but it is probably a titration because you're adding an acid. Oh, I need to do my, stop it. There we go. All right. So you have an acid, and this guy will act as a weak base. I'm not going to tell you the details of how it happens. It also is a gas evolving reaction because you have two aqueous solutions and you end up with a gas being produced. Okay, so this one can actually be considered an acid-base reaction and a gas evolving reaction. And you could do this as a titration because it's giving you a volume and a molarity. Okay, let's just treat it as a simple stoichiometry problem to start. It says, what volume in mils of HNO3? So let's kind of do our route plan. We are looking for milliliters HNO3. And we'll use this as a conversion factor. And cut that one off, but it said 0.02 molar Na2CO3. Okay, it was the other reactant. So that's also going to be a conversion factor. So the only place we can really start is with this volume of Na2CO3. So we're going to start with milliliters of Na2CO3. We're going to go to moles Na2CO3. Then we're going to go to moles of HNO3. And then we can go to milliliters. So in here, this is going to be your molarity as your conversion factor. Here, this is your balanced equation. And here, this is your molarity. Now, I'm pretty sure in lab, he told you guys to use the M1V1, M2V2 equation for titrations. That only works if the reaction that you're looking at in a titration has a 1-to-1 ratio. So you cannot do that here because there's a 2 in front of that HNO3. Okay, so we're going to treat it just like any stoichiometry problem. All right, so debating where I have enough room. I'll start down here at the very bottom. Maybe I can make this bigger? No. All right, so I've got 34.8 milliliters, and I'm just gonna put this SC for sodium carbonate, because I don't wanna write that every time. Okay, I'm gonna convert that to liters, because I can't use molarity until I'm in liters. Then I look at the molarity, it's 0.102 molar, which is 0.102 moles per liter. So 0.102 moles of sodium carbonate per 1 liter. Now from the balanced equation, 1 mole of sodium carbonate for every 2 moles of nitric acid. I'll label these Na and SC. Just trying to save space here. Now, to get to the volume, I need to use the molarity of the nitric acid. So that's 0.2 moles nitric acid per liter. So I'm going to put the moles on bottom, 0.2 moles nitric acid per liter. And then I need to finish this off by putting it in milliliters. Did anybody try to go back this morning and check the answers to see if they're there? And that will give you the answers now? Will you look at it and see? I didn't know if I needed to change the setting after the due date or if it would automatically do it. Like, just put in a wrong answer and see what it tells you.
It still says
Withheld? Okay, I'll go in right now and change it. Okay, so this comes out to be 35.50 mils. So if you notice that it's an equation like this, a volume and a molarity, a volume and a molarity, and it happens to be a one-to-one equation, sure, go ahead and use M1V1. Usually the time when we use that equation is when the chemical isn't changing. So like you have nitric acid and you're just adding water to it and you're making more dilute nitric acid. That's when you would usually use that equation. Yep. Yeah, so both of the not the product. It's not the product that actually matters in this instance. Basically, whichever two you're looking at, like here you're looking at HNO3 and Na2CO3, those two would both have to have ones in front for it to work. And there are a lot of those. That's why people will say, oh, we can just use this, because most acid-base reactions are a 1-to-1 ratio. The only time they're not is when you have a base, it's never the acid, because you don't do those both at the same time. When you have a base that has 2 units that are going to accept that hydrogen. We see it most of the time with stuff like calcium hydroxide. So those 2 hydroxides are both going to take a water, and that's why the acid would then have a 2 in front. So just check that if you want to do it that way. Okay, I'm going to turn this on for a second and just go change that setting so that I don't forget later. Grading and presentation settings. Save for this assignment. Will you go check again now and see if it's working? Okay. To get the most credit, I'm okay. Oh, you clicked the correct random answer. Try again. Try harder to not get the right answer. Wait, you did the same? You got a correct answer? Now it's showing you the answer? Yes. Okay, great. So apparently I just have to manually do that. I think what I'm going to do in the future is, instead of giving you guys multiple assignment attempts, I just have to give you multiple question attempts. And if you can never go back and do the question, then it'll show you the answer once you've used all your attempts. I just like forcing you guys to do it all. It's better studying. It's a pain for you, but next time. We actually usually do an assigned review assignment in Chem 2 before every test, like it's part of your grade. And in that one, I do just do like 2 trials, and then it gives you the answer. So, yes. 47. Okay, so this was the one that I emailed about. And it kind of just depends. Oh, no, this is the one that I emailed about, and it's like totally you don't have to do it. So let's do one that's not this one.
It's like I can do it. I want to know why.
Oh, no, you don't.
Yes, I do.
Then ask me after class, because
Okay.
nobody else does.
Okay.
The short answer is that transition metals, sometimes, because the S and D orbitals are so close to each other, sometimes instead of having a full S and somewhat of the D, they would rather have all of them half empty. And it's similar when you lose the electrons. So when you lose them, it loses 1 from the S and 1 from the D, so that you end up with all 6 of those orbitals half filled. I feel like I did just answer it. If that's not enough of an answer, no more. Okay, let me give you a question similar to this. Was yours related? Okay, let me just come up with one. I used calcium 2+ in the email, but let's just say, like, why don't you give me the electron configuration for nitrogen 3 minus. Yeah, let's do that. So just, 1 minute, work through that, and then we'll talk about it. I want the longhand version, mostly because this is only in row 2, so who cares? Okay, so normal nitrogen should be 1s2, 2s2, 2p3. So the ion means I gained 3 electrons. Where do those 3 electrons go? They just fill up that p orbital, so it would be 2p6. And the main group elements, they always lose or gain in order to become isoelectronic with a noble gas. Like this is now the same, so this is 3 minus. This is now the same as neon. Okay? So that's what's gonna happen with all of these. They're gonna gain enough electrons, if they're a nonmetal, to get to the next noble gas. Now, you can't just write neon. You need to actually write it out. Even if I'd said abbreviated for N3 minus, I would still expect helium 2s2, 2p6. Because I need to know that you know what neon is. And then metals in the main group lose enough electrons to become like the noble gas that's in the row before them. Okay, I think there was another one, right? Nope, copy and delete, whatever. Which one? 33. I don't think I've even looked at this one since I assigned it. Like no one's asked a question yet. Okay, here's a picture, 1 atmosphere, 1 liter, 25 degrees C. So this is not STP because standard temperature, although it seems like it should be room temperature, it's a gas, and gases are more whatever. It's 0 degrees C for STP. Okay, what would be the pressure? So we're looking for a pressure if the volume was reduced and the temperature was increased. Great question to do. All right, so on your exam equation sheet, you guys have the ideal gas law written as 2 ways, PV equals nRT, as well as R equals PV over NT. And the reason I did that was to set up how you approach an equation where some of the variables are staying constant and some are changing. Okay, so I'm gonna take that version and I'm gonna set up a first condition and set that equal to a second condition, because I know both of them have to equal R, that's why I'm able to do this. And then I'm gonna cancel out anything or erase anything that doesn't change, okay? So the number of moles didn't change. The volume was changing and the temperature was changing, and then that had an effect on the pressure. So I'm just gonna remove N from this equation. And now at this point, I just need to make sure that I put everything in the right place and that I change the units. So I know I moved it, but this question, or I guess I just cut it off when I did the screenshot. Initially, the pressure was 1 atmosphere, and I like to do it this way, like write down a list so that you don't, I don't know, get confused about which one is 1 and 2 as you're trying to put it in. And then temperature 1 in Kelvin, you have to convert. Even if you're doing this change thing, you have to convert. So 298.15 Kelvin. And then P2 is the thing we're looking for. Oh, that was supposed to be a question mark. V2 is 0.4 liters. And T2 is 249 plus 273, 522.15 Kelvin. Okay, so now I'm going to go plug those all into that equation. So I'll go ahead and do it if you want to follow along, or if you want to do it yourself, that's fine. I'm going to be lazy and not include the units because I just know that they're going to work out right now, so. Now, I don't tend to do it in individual steps like this, but I also find that when you guys don't, sometimes it causes issues. 1, 2, 3. 1, 2, 3. So I'm doing it that way right now. So P2 equals as long as I put my right zeros in, I should have this right. 4.63, and that's in atmospheres. My issue came when I was like blind and couldn't tell if there were the right number of zeros. Anybody else get that? Anybody else punched in their calculator? So this is why you don't have to memorize the individual laws. You don't have to memorize Charles' law or Boyle's law or whatever. You just always pull it out of this original relationship where you have R equals PV over NT, and then just eliminate whatever you don't need. So Boyle's law holds N and T constant. So I erase those and I just say equals P2, V2. Yep.
But it said I got it wrong. And then I did practice, and then the same answer.
Yeah. Is it, because it says here, express your answer in atmospheres to one significant figure.
Yeah, like I literally.
So did you report it as 5 atmospheres?
No, like I have different numbers.
Oh, you have different numbers. Okay.
Just 4, and I put 4 in the first attempt, and it said it was wrong. It gave me the correct answer, and it said 4. And then I did on practice just to see if it was like the same thing.
Yeah.
And so it's
If you want to send me a screenshot, since the assignment's due already, send me a screenshot and I'll give you that point back because, like, that's weird. I've noticed on some of them, it will not even ask about sig figs. And it might tell you that you got the sig figs wrong, but it doesn't count it wrong. And then, but the ones where it tells you to report it in a certain number, then it is going to count it wrong. I like that a little bit since we are reviewing sig figs. Normally I'm like, please don't make them mess with sig figs right now. But for right now, I do like that. Yeah. 42? Okay. Okay. Well, maybe I'll give a rough outline and then I'll finish it for those that are like, wait a second, I want to know that. Okay. So the equation we're using here, yeah, and I won't do the whole thing because the whole thing, you're just gonna repeat it 3 times. I was like, it did it right, but then it wouldn't let me get my pen. Okay, so the equation you're using here is that energy equation, negative 2.18 times 10 to the negative 18th, 1 over n final squared minus 1 over n initial squared. Now, the negatives I know throws people. This is asking for a wavelength, and we never report wavelengths or frequencies as negative. So you literally just drop the negative, okay? And I won't even ask you about energies, negative or positive, so you don't have to worry about that. I had one that I had pulled from like a test bank, and it had negative and positive options for something, and I just deleted those and made all of them positive. And I changed the question to really read like how much energy is released, so that you know that that's energy released, and then you don't worry about the sign. Okay, so in this one, you're going to have to first solve this equation. Then you're gonna have to do this equation. So you plug this energy into here to solve for the frequency. This is a multi-part one where I would cut this into maybe 2 separate ones. So maybe at this point is where I would be done. I would say like match the frequency associated with each of these transitions. So I would take 2 and 1, plug them in here and here, find the energy, find the frequency. In this example, it asks you for wavelength, and its wavelength in nanometers. So you would have to go ahead and do C equals lambda nu, and now take the frequency and plug it in there. And then you would have to find the wavelength, from that equation, and that'll be given in meters when you get it out. And so at that point, you're gonna have to multiply by 10 to the negative 9th to get it in nanometers. So let's maybe just do one of them, unless somebody else has like a pressing one. They're like, I really wanted to ask this. Yes, you do. Which number was it?
37.
37, okay. All right, do you feel good about this though? Okay, all right, we'll do 37, we can always come back. Delete, okay. Oh, I think I remember this one. Is this the one? Okay, argon and neon. Yeah. So this is, it's not a bad question. I probably would not give you something this hard, but it does incorporate a lot of smaller things. So like even the end, it's multi-part, and there's one part that's really hard that I wouldn't give you. Okay, so you've got a mixture of neon, because it says this many grams of neon is added to a bulb. So this is, we're gonna need to put that in liters. That's your volume. Just so everyone knows, centimeters cubed is the same thing as milliliters. And then it says it has some argon, and it gives us the total pressure and the temperature. So they're saying pressure of neon plus the pressure of argon is equal to 1.14 atmospheres. Okay. And we are looking for the mass of argon. So we actually do have everything we need to solve for the pressure of neon. This isn't the one I was thinking of, but that's okay. So I'm gonna rewrite this as how we would solve for pressure of neon. So we would do moles of neon, RT, over volume, because volume is for the whole thing and T is for the whole thing. And then we would say plus pressure of argon equals 1.14. Okay, so if we plugged in all of the stuff there, we plugged in this, we solved that for moles of neon. We solved this for liters, this is already in Kelvin. We could actually determine now what the pressure of argon is. Then we're gonna set up pressure of argon times the volume equals N of argon, RT. And then you're gonna solve for N, the moles, and convert that to grams. So I don't actually, this isn't the one I was thinking of. Would I give this to you? Probably one of the two parts, not both of them. Okay. Which day is your test? I keep getting them confused. Thursday? Is it Thursday? Okay. If you, for some reason, want to take it Tuesday or Wednesday, you have to send me an email. Otherwise, I'll see you Thursday. I am on campus Tuesday and Thursday, so if you need to meet, you can email me. But we have to like set up a time because I'm going to be giving finals elsewhere. Good luck. Keep up the studying. Now you can go back and look at this whole assignment with the answers, so it's still a really good study tool. Nope, no class on Monday. I don't even, is that even a class day? Psh. Maybe I'll just send you guys an email and say I'll do office hours on Google Meet or something.
I was gonna ask that because I have to take a redo test on that day.
Yeah.
So it's like at 9 a.m. So I was
No, I was not planning on having class. I actually
Okay.
thought that was the beginning of finals week. I thought that was a finals day.
Yeah.
Whatever. We'll count it as a reading day for our class.
So you said that dynamic models we can't do it again because it might mess up the scores.
Yes.
Is there like a way that we could like screenshot like the videos you have and then send it to you? And then go back and do this?
Yeah, in fact, because you just want to use them.
Yeah, that's
Yeah.
also.
Yeah. No, that would be fine. In fact, I like your way of doing it. So I probably can go back in. I don't actually know that I can. So yes, take a screenshot just to be sure of like, you know, where it says that you already earned 100%, and then go ahead and start them. And just email to me and that should be fine. Yep.